Hi, this is Shavana, working as an assistant professor in the Civil Engineering College. Today, I want to discuss about the reaction mechanism of the polymer, which I discussed. I'm continuing from the video lecture 2. And in the reaction mechanism, addition or chain growth polymerization involves three types of polymerizations. They are radical polymerization, cationic polymerization, and anionic polymerization. Coming to the free radical polymerization, free radical means it is a odd electron pair or it is a unpaired electron. In this free radical polymerization also, it involves again three steps. They are initiation step, propagation step, and termination step. First, the radical generation should be taken place before involving in the mechanism. In the radical generation, the initiators is, that is RR, it undergo homolytic fission. Homo means same. It undergo the bond cleavage equally. This bond contains two electrons. After the fission of the bond, one electron goes to this R and another electron it goes to this R and it forms and it generates the radical of 2R dot. And after that, the mechanism involves the first step, that is the initiation step. In the initiation step, this R radical, one of the R radical among the two, it come and react with the monomers. It is a C double bond C. In this C double bond C also, this double bonded carbon, one of the double bond, that is one sigma bond and one pi bond is there. The bond cleavage should take place on the pi bond. That is a homolytic cleavage. And one electron is distributed to this carbon and another electron is distributed to this carbon. And this electron distributed to this carbon, it will get bonded to this R radical and it forms RC bond with radical dot. This is the initiation step. Coming to the propagation step, whatever the product form in the initiation step, it made to react with another monomer. In this way, the chain growth takes place. Chain growth takes place in this manner. Here also the same type of mechanism involved. That is the bond cleavage takes place and you will get one electron to this carbon and an electron to this carbon. This electron and this electron, it forms a bond leaving behind one electron to this carbon. In this way, the chain growth takes place. After that, the chain should be terminated at one point. That is called termination step, which is also known as the death of the polymerization. In this, whatever the product form in the propagation step, it is made to react with another radical and this unpaired electron and this unpaired electron, it forms a bond. So this forms the polymer and ends the mechanism of polymerization. So this is about the chemistry which is present behind free radical polymerization. Coming to the next one, there is an overall view of the free radical polymerization mechanism. The free radical mechanism or polymerization process involves at least three mechanistic steps. First one is the initiation step. Second one is in the initiation step. First, the generation of the free radical will take place. After the generation of the free radical, it is made to react with the monomer to form a bond between the initiator and the monomer. And next, coming to the propagation step, whatever the product form in the initiation step, it is made to react with the another monomeric unit, and it forms a chain growth process with the radical. So this one. After the bond formation between the monomer 1 and 2, it is made to react with the another monomeric unit, and in this way the chain growth takes place. See here, up to mx. After that, termination will take place. In the termination takes place either by the combination of the reaction, which is also known as the radical coupling, or it is also ends or terminated by the process called beta hydrogen transfer, or it is also known as disproportionation reaction. Beta hydrogen transfer or disproportionation reaction. Coming to the first process, that is the radical coupling. Radical coupling, that means two radicals will get coupled to terminate the chain. See here. This initiator mx dot plus initiator my dot. This is one radical, free radical, and this is another free radical. This will get united to form a bond like this. What I discussed in the last one. See here. Here. One free radical and another free radical. It forms a polymer by the process called coupling, radical coupling. And coming to the next process of termination is a disproportionation reaction. I already told it is a beta hydrogen transfer. That means beta hydrogen means whatever the hydrogen that is present on the beta carbon, it gets transferred. It gets transferred to another carbon. So this is a beta carbon, and this hydrogen is called the beta hydrogen. It gets transferred to this carbon atom. It gets transferred to this carbon atom and forms a bond, leaving behind, see here, initiator mx CH. This will be migrated to this carbon, leaving behind only one carbon, hydrogen atom there, CH, and this bond will be left over. After the removal of this hydrogen, this bond will get left over and it is transferred between these two carbon atoms. This bond get transferred to this carbon atom and forms CH double bond CH2. And another product is, see here, this is initiator My CH2, and here after the hydrogen transfer, it forms a bond here and forms CH3. So this is the disproportionation reaction which terminates the chain. So this is about the free radical mechanism. Coming to the next polymerization, that is anionic polymerization or ionic polymerization. In the ionic polymerization, only two types of polymerizations will take place. We will learn about the ionic polymerization. The addition polymerization that takes place due to ionic intermediates. Some sort of intermediates will be formed during the process of the reaction. That intermediates, if they are ionic, then the type of polymerization that takes place is the ionic polymerization. Based on the nature of the ions, that means if the nature of the ion is a cation, then the type of polymerization was cationic polymerization. Suppose If the nature of the polymerization or nature of the ion is the anion, then the type of polymerization that takes place was the anionic polymerization. So yes, here, based on the nature of the ions used for the initiation process, ionic polymerizations are classified into two types. They are cationic polymerization and anionic polymerization. Coming to the first one, that is a cationic polymerization. Cations means these are positively charged species. These are positively charged species or positively ionic species. So this polymerization depends on the use of cationic initiators, which includes the reagent capable of providing the positive ions or H plus ions. The example for this is aluminum chloride with water. Aluminum chloride AlCl3 with water plus H2O, or boron trifluoride with water BF3 with water. These are effective with monomers containing electron releasing groups like methyl group or phenyl group. So this type of reagents will be very effective with the monomers which are having electron releasing groups like the methyl group or phenyl group. They include propylene also and styrene. This cationic polymerization also, this polymerization is also involves three types of steps. They are chain initiation step, chain propagation step, and chain termination step. Coming to the first step, that is a chain initiation step, decomposition of the initiator is shown here. First initiator should be decomposed. If BF3 plus water, if we take as an initiator, it will dissociate like this, H plus and BF3OH minus, because this H2O will be dissociated as H plus and OH minus ions. This H plus ions will comes out like this, and OH minus ion will get and combine with the BF3 as BF3OH minus. So this H plus will add to the carbon-carbon double bond. Will add to that of the carbon-carbon double bond, that is a vinyl monomer. This is called vinyl monomer. Vinyl means if the functional group, if the functional group is directly attached to the carbon-carbon double bonded carbon. This functional group is directly attached to the carbon which are having the double bond. It is called vinyl monomer. If this released H plus ions, if it is get added to the vinyl monomer, then you will get the carbocation. That means the bond of the one of the bond of the double bond. This bond is a sigma bond, and this bond is a pi bond, which is weaker. This pi bond is weaker than the sigma bond. It gets fission. It undergoes fission, and here in this cationic polymerization, it undergo heterolytic fission. It undergo heterolytic fission. That means the fission of the bond takes place unequally. The fission of the bond takes place unequally, migrating all the two electrons to any one of the carbon atom. This bond contains two electrons. Heterolytic fission means if these two electrons will be migrated to any one of these two carbon atoms. Suppose if these two electrons will be migrated to this carbon atom, if these two electrons, if it is migrated to this carbon atom, this carbon will acquire the negative charge and this carbon will acquire the positive charge. This carbon will acquire the negative charge and this carbon will acquire the positive charge. This negatively charged carbon atom, it forms a bond with the H plus, that is a proton acid. It forms a bond with H plus because this is a H plus and this is minus. Plus and minus will form a bond and it will get the CH3, leaving behind the positive charge to this carbon atom as a carbocation. In this way, the carbocation will be generated in the chain initiation step. And coming to the next step, that is a propagation step, the whatever the carbocation which is formed in the initiation step, it is made or it gets added to the carbon-carbon double bond of another monomer molecule to form a new carbocation. See, it is another new carbocation. And in this way, the step gets continued and forms a chain growth process. See, here also, this bond gets heterolytic fission and two electrons will be migrated to this carbon. And this carbon will get the negative charge and this carbon will get the positive charge. This negatively charged carbon and this positively charged carbon, it forms a bond and forms CH bond CH2 and leaving behind the positive charge to this carbon atom. In this way, this process will get repeated and forms a new carbocation. And next, coming to the third step, which is known as the chain termination step, the reaction is terminated by the combination of carbocation with the negative ion or by the loss of proton. It will get combined with the either with the negative ion or the chain gets terminated by the loss of proton. Two processes are there for the chain termination. Either by the combination with the negative ion or the chain gets terminated by the loss of proton. Here, this is the product which is obtained from the propagation step. It gets reacted or it gets combined with the negative ion, that is sulfate ion, HSO4 minus, which is called the sulfate ion. The reaction takes place, that is the combination takes place, and it forms the product by the loss of proton. See here in this, beta hydrogen transfer takes place by the process called disproportionation reaction. Beta hydrogen. This is the functional group which is attached to this carbon, and this carbon is called alpha carbon. And adjacent to this carbon is called the beta carbon. And the hydrogen attached to this carbon is called beta hydrogen atoms. Beta hydrogen atoms. So the chain gets terminated by the transfer of one of the hydrogen of the beta carbon atom to the sulfate ion, because sulfate ions acts as dehydrogenation. That means it removes the hydrogen from the beta carbon atom and forms H2SO4, which is called sulfuric acid. And after the removal of the hydrogen from this carbon atom, whatever the bond which is left over will get migrated to this bond and forms a double bond. In this way, the chain gets terminated in the cationic polymerization. So this is about the cationic polymerization. Coming to the next polymerization is the anionic polymerization. Anionic polymerization, it depends on the anionic initiators. In the cationic polymerization, it depends on the cationic initiator. Obviously, in the anionic polymerization, it depends on the use of anionic initiators, which includes the reagent capable of providing the negative ions. And thus, the typical catalyst includes are sodium in the liquid amalgam, alkali metal alkyl, Grignard reagent, and triphenyl methyl sodium. This is a triphenyl methyl sodium. They are effective with the monomers containing electron withdrawing groups. In the cationic polymerization, they are effective with the monomers contain electron donating group. Here in the ionic polymerization, they are effective with the monomers containing electron withdrawing groups like nitrile or chlorides. They include acrylonitrile, vinyl chloride, methacrylides, etc. So these are the examples of the anionic polymerization. Coming to the mechanism of the anionic polymerization, here the generation of anions will take place first one. The generation of anions will take place, which may to react with the monomer. Here, sodamide. This is the name of is a sodamide, NaNH2. It gets dissociated as Na plus and NH2 minus. This NH2 minus, which is called the anion, it made to react with the styrene. This is the structure of styrene. CH2 double bond, CH, C6H5 is called the styrene. Here, the bond of one of the bond in the double bonded, this pi bond, this bond undergo heterolytic fission and the two electrons is migrated to this carbon. The two electrons of this bond, hetero means the fission of the bond takes place unequally and the two electrons of this bond is migrated to this carbon and this carbon will acquire the negative charge and this carbon will acquire the positive charge. And this positive charge carbon will form a bond with NH2, Cr, NH2 bond CH2, and left over the two electrons of this bond to this carbon atom as like this, and the negative charge will be there. So, in this way, carbocation will be generated in the first initiation step. Next, coming to the propagation step, the propagation proceeds in the usual manner, as in the case of the cationic polymerization. That means whatever the carbene ion, this is called carbene ion. Whatever the product that is formed in the first initiation step, it is made to react with the another monomer of styrene and the chain group takes place like this. The chain group takes place like this. So this is the initiation and propagation step of the anionic polymerization. Coming to the last step, that is a chain termination step. In this step, if the solvent that is able to release a proton is used, it can react with the active site. Ammonia is the best example of such a protic solvent, and the reaction results in the formation of negatively charged NH2 ion, which can initiate the polymerization of a new chain. In other words, we have a chain transfer to solvent. So in this way, the chain termination takes place. So this is about the condensation polymerization. So in the addition polymerization, free radical mechanism takes place. In the condensation polymerization, both ionic polymerization, that is a cationic polymerization, and anionic polymerization will take place. So coming to the third type of polymerization, that is a coordination polymerization. Coordination polymerization. It is also the subclass of additional polymerization. It is also come under the additional polymerization. But the difference between the addition polymerization and the coordination polymerization is In the addition polymerization, two same types of monomers are united together to form a polymer. But in the coordination polymerization, two or more different monomers are united together to form a polymeric chain. And this polymerization involves transition metal catalyst. Transition metal catalyst means whatever the metal that is present in the transition state or transition block elements, D block elements. So this type of metals acts as a catalyst in the coordination polymerization. Here, the active species is a coordination complex. In this, the complex will be formed, which initiate the polymerization by adding the monomer carbon-carbon double bond. The most important catalyst for the coordination polymerization is called Ziegler Neta catalyst, discovered to be effective for the alkene polymerization. So, in the coordination polymerization, the first and the foremost important catalyst used for this type of polymerization is a Ziegler-Neta catalyst. Ziegler-Neta catalyst combines the transition metal compound such as chlorides of titanium with organometallic compounds. So, titanium chloride, trichloride with trialkyl aluminium. This is trialkyl group. Trialkyl aluminium. An important property of this catalyst is it yields the stereoregular polymers. It yields the stereoregular polymer when higher alkenes are polymerized. Example, polymerization of propene produces polypropene with higher selectivity. Branching will not occur through this mechanism since no radicals are involved. The active site of the growing chain is a carbon atom directly attached to the metal. It is a carbon atom directly attached to the metal. So it is a special type of coordination catalyst. And this catalyst consists of chloride of titanium or chloride of titanium, either the titanium trichloride or titanium tetrachloride, with a co-catalyst of organometallic compounds, that is triethyl aluminium. So this two combinations is known as Ziegler-Neta catalyst. This triethyl aluminium, it acts as an electron acceptor, whereas this titanium trichloride or titanium tetrachloride, it acts as an electron donor. This acts as electron acceptor and this acts as an electron donor. And therefore, by the combination of these two, electron acceptor and electron donor, it readily forms the coordination complex. It readily forms the coordination complex. So the complex will be like this, which acts as an active center. Which acts as an active center. Next, the monomer is complexed with the metal ion of the active center in the way that monomer attached towards the titanium carbon bond in the active center, where it forms a pi complex with the titanium ion. It forms a pi complex with the titanium ion. The bond formed between the R and the titanium opens up, producing an electron deficient titanium and carbene ion at R. And this titanium attracts the pi electron pair or the monomer and forms a sigma bond. See here, it forms a sigma bond. The transition state now gives rise to the chain growth at the metal carbon bond, generating the active center. Repeating the whole sequence with the addition of the second monomer molecule, we will get the structure of the resultant chain growth. So this is about the condensation polymerization.